So let me kind of give you some hints. So this is old school momentum, like number one, old school conservation of momentum. Okay, old school. Momentum of Timmy plus the momentum of the rock in the boat. Number two, force exerted on the rocket by propelling gases are exchanged at a rate of 1,500 kilograms per second with a speed of 400 meters per second. Okay? So, let me give you, and this is the hint that I told you. Look at what's going to happen. So, I've given you the change in mass per unit of time. So, this thing expels 1,500 kilograms per second at 4,000 meters per second. How much force are you going to have? When you get to number three is conservation of energy. You're going to compress a dart against a spring constant. You're going to compress it 6 centimeters. You're going to let go. Dart's going to go flying off. So conservation of energy. On number four, solid cylinder, 3 kilograms, radius of 0.2 meters, tangential force of 12 newtons is applied for 10 seconds, determine the angular acceleration of the cylinder. On number four, can you take force and divide it by mass to get the acceleration?
No.
No, absolutely not. Now, when you get to 12D, it says determine the work that was done on the cylinder. Remember, work can equal the change in any type of energy. What do you think the initial rotational kinetic energy of the solid cylinder is going to be?
Wait, when we get to what question?
4.
Oh, 4. I thought you said 12D, and I was like,
I was
what?
No, I think I saw the 12 newtons. That's number
Okay.
4.
I was like,
No.
okay.
When you get to number 5, you got a mass moving to the east, collides head on, that's at rest. If collision is perfectly elastic, what would the velocity of each be after the collision? So this one I tell you specifically, this is a perfectly elastic collision. Now, when you get to number 7, okay, it's at rest, they move off together. Now, do you think if two objects move off together, do you think that could be a perfectly elastic collision? No. Why? What are they going to share if they move off together? The same velocities. You're not going to have two separate velocities. So anytime you have a California problem, that cannot be a perfectly elastic collision.
California problem? That's what it's been called.
Yeah.
Where have you been?
Asleep. Mentally gone.
You're
Just ignore me.
dishonest.
Just ignore me. I say words. I
When
don't
you
mean
get to
them.
number 10, this is the Earth-Moon system. If I were you all, I would let the position of the Earth be 0. And then you're going to have the position of the Moon. Okay? So, when you get to that answer, I say, where's the center of mass located? Is the center of mass inside the Earth or out in space? Let me give you a hint. It should be inside
Space.
the Earth.
Wait, what
Inside
number?
space.
Number 10. It's
Number 10. Then you've got some multiple choice questions as well. So, all right, I'm done. You're on your own. Be free. I know you guys have to go.
Is the center of mass like high and low tide? Because in the Earth, it's like slightly shifted. It's like the water.
But it's the water just stays there. It's the Earth that spins underneath it.
Is that what causes it?
Yeah, because that's always being pulled towards the moon, and it's the Earth that spins underneath that bulge.